patterns in sequences and differentiating between an arithmetic and a geometric sequence, as well as extending that sequence. Today we're going to take specifically arithmetic sequences and use this arithmetic formula, which is y equals start plus change times the quantity x minus 1, to come up with our formula. In our case, start is the first term and change represents that common difference that we talked about yesterday. So when we take a look at our first example today, we've got 4, -1, -6. Our first step is going to be to determine that common difference. So when I look from -4 to -1 and -1 to -6, each time I'm subtracting 5. So I end up with y equals the start value, which is that 4, plus our change, which we said is that common difference of -5, times that quantity x minus 1. So now we've just gone about using that formula, and our final step is going to be to simplify. So we're going to go ahead and distribute that -5 to the x into the -1, which will give us y equals 4 plus -5 times x is -5x, and -5 times -1 is +5. In further simplifying, we are going to combine our like terms of 4 and 5 to get y equals -5x, and we put that first because remember we want things in standard form. And then we have 4 plus 5, which is +9. So therefore our equation or formula we're looking at is y equals -5x plus 9. Moving to the next example, we've got 2, 8, 14. To get from 2 to 8 and 8 to 14, we're going to be adding 6 both times. So when we go ahead and create our formula, we have y equals that start value of 2 plus our change, which is going to be that +6, times the quantity x minus 1. So then we can go ahead and distribute the 6 to the x and to the -1, which gives us y equals 2 plus 6x minus 6. And then finally we can combine that 2 and that -6 and put it in standard form to get y equals 6x minus 4, because 2 minus 6 is -4. Moving on to the next example, I want you to go ahead and take a minute and see if you can come up with an answer to this problem. And while you do that, pause the video and then hit play again to check your work. When I take a look at the common difference from 3 to 4.5, 4.5 to 6, and 6 to 7.5, I'm adding 1 and 5/10 each time. So when I create my equation, I get y equals that start value of 3 plus the common difference, or the change, which is 1.5, times that value of x minus 1. So then I can simplify by distributing that 1.5, which will then give me y equals 3 plus 1.5x minus 1.5. Finally, I combine my like terms and put in standard form to get y equals 1.5x plus 1.5, because 3 minus 1.5 is 1.5. Again, pause the video for example D and see if you can solve it on your own, and then come back and press play again to see if you got it right. Taking a look at this problem, let's see if you got it right. From 1/4 to 1/2, 1/2 to 3/4, and 3/4 to 1, each time we are adding 1/4. So when I create my equation, I've got y equals my start value of 1/4 plus my common difference, or the change, which is also 1/4, times the quantity x minus 1. So then I can go ahead and distribute that 1/4, which will give me y equals 1/4 plus 1/4 x minus 1/4, which is an awful lot to deal with. So then, when I simplify, I have a positive 1/4 and a negative 1/4, which conveniently cancel, which gives me a final equation of y equals 1/4 x. What I want you to do now is to go ahead and take a look at these two sequences of -2, 3, 8, 13, and 2.55, 7.5, 10 to write the formula for each of these sequences. Bring any questions you have to class, and as always, see if you can get your summary written.